Hey, welcome back on the Malachite tutorial. Today we are on part 3.4. We're gonna talk about ID attributes. So let's dive in. Right, this is where we left, and the first thing I wanna address is the crystal geometry that we generated. If we look pretty closely, we got some kind of cubed artifact that's been created while we were reshaping the volume with this little section here. So first thing is that I'm gonna decrease the resolution of the voxel so that it's going a little bit faster. Maybe not that low. Yeah, that's all right. Let's go inside the volume VOP, and basically the AA noise is what's causing this artifact. I haven't found any elegant solution to solve it yet, so I would rather replace it by a unified noise. So I'm setting the fractal type to standard, changing a few settings, increasing the frequency, and we're gonna switch the type to Wally cellular. Alright, so that should be replaced by a add node. We're gonna have to adapt a few things, so let's plug that instead of the AA noise. And also, since we are adding this noise, we're gonna have to switch the source max to the source min, like so. So now we see some things happening. That's pretty cool. So from now, if we try to increase the destination minimum, it's basically re-aging some of the initial volume back in the final SDF. So it's pretty convenient. And the advantage is it seems to be clean enough compared to the AA noise. One thing we could add is a controller based on the height of the crystal, and this controller is going to be a ramp, like a spline ramp. We're going to call it breakup control, and it's going to allow us to localize where we want noise to be applied on the crystal. So I'm going to try to mix that with a max node, and if we try to play with the spline, well, it seems to work, but actually we got some clipping, so it's looking a bit weird, but you get the idea is that we can control this spline to affect where we want the noise to be applied. So instead what we should do is expose the source min, and we're gonna multiply it by this ramp. Let's delete this, and I think that should work. Yep. So you could play with that to find some interesting breakups. I'm going to increase the resolution so that we get more detail. Alright, and if we go back to the final output crystal node, seems to work pretty well. I'm going to iterate the version to 2 and save. Okay, and now it's time to create different variation of this crystal. So I'm copy pasting the crystal geometry node, calling it crystal B, and let's go back to the top nodes, and we're gonna do some changes. Let's make one that's like a bit bigger, and we're gonna also play with the rotation of the platonic solid we created to boolean the tube. This way the top should be a bit different. Right, now let's go a bit further. So would be on the cluster area. Could play with the scatter force total count. So actually I would need to add a little more pieces in here first. Okay, that's interesting. So basically from now it's just playing with all the parameters we created in the first part and trying to find interesting shapes. Could play with the global seed to try different variation, And if we are happy with that, let's keep going. I think I'm pretty happy with this level of extrusion, so I'm not gonna touch anything here. And okay, here that seems all right. Some cool breakups. And back in here to the volume. Well, I guess we could play a bit with the noise and the ramp. I'm gonna dive inside and probably increase the frequency. Got some pretty cool breakups on the top. We could also try to play with the offset to bring variations. So back in here, we're gonna play with the global seed of the different chunks. If you got smaller crystal, we could decrease the number of particles so that there is less chunks, basically. And here we're gonna call that crystal B. And save to disk. You could play with any parameters, and that's what I ended up created, those different variation based on what we just saw. So let's just make a group out of that. So all of these are available in the provided heap file, so you can have a look at it if you're interested. So from there, we're gonna go back into the rock attributes and let's load all these little crystals. So we got crystal A version 2. I think that will work better, and let's copy paste the file node and start adding all the others. We'll have B, C, and crystal D. Right, so for now this stuff I'm gonna put that aside and create a switch node. So the switch node is basically gonna control which of this geometry to apply on the point. But to do that, we're gonna need to create an ID attribute. So let's copy paste the point VOP P scale we created, and we're gonna call that point VOP ID. Well, that was why we spent so much time cleaning it. It's because we keep reusing the same stuff, basically. All right, so actually I might need to put this node after, because we want to apply the ID straight to all the different points, the scattered points, those points. Cool. So inside, we're gonna replace the P-scale export attribute to ID. So now we should have an ID attribute that's been created. It's currently going from 0 to 0.5, something like that. And what we want is like apply an integer value between 0 and 3 to control the switch. So let's try and play with those 0 and 3. If we check out the spreadsheet, we now have like some float value between 0 and 3, but we're gonna add a floor node so that it's trunking the values to an integer. And let's set the max output to 4 so that it's actually between 0 and 3 and not 0 and 2. Okay, so from here, we're gonna create a color for all those points. So I'm applying a ramp parameter and plugging that into the color and gonna call that ID color. The problem is that right now those values are going between 0 and 3. So I'm gonna expose this parameter, which was the destination max, the maximum value of the different IDs we have, and subtract 1, a constant value of 1, so that we end up indeed with the values we have in the spreadsheet between 0 and 3. So I'm applying different colors so that the red would be the ID number 0, green 1, and blue 2, and so on. So actually the subtract should go into the source max so that it's refitting all the values of the ID to between 0 and 1. And now we got a proper color for those guys. Okay, that's great, but we need to control the shape now. and we're gonna need a for each point loop. I'm plugging that after the ID, and as you can see inside, it's basically isolating every point and iterating through all of them. So let's make sure that the method is in merge iteration, and copy the copy to point inside. Plug it properly. And in the switch node, we're gonna use a point expression function that's basically driven by the surface node, the point number, the attribute, and an index to change the shape. So let's use point, and the surface is gonna be the for each begin. And well, the point number is 0, it's always 0 inside the loop, and the attribute we are calling is ID. The index is 0 because it's a float, it's not a vector, so we don't care about the index. So as you can see, if we compare before the loop and after, we do have some shape changes now. Yay! That's pretty sweet. If we want, we can swap all the different inputs if we want to replace some of them, like I'm swapping the crystal A and D. That sounds a bit better to my taste. Let's delete this one. What we could do is pack and instance those guys so that it's going a little faster, and it's basically replacing by a little box if it's get too heavy. And we could also, of course, play with seed random or use noise. Like for the other attributes we created, we have this controlled now. So we'll see a bit later how we can fix the intersection. Otherwise, gonna be time to talk about the fibers.